It is now, yeah.
Yeah, cool. All right. So the probably the most exciting thing that you should know about today is yesterday I wrote the exam for this subject. Woohoo! So that was a fun experience. I'm sure you'll have just as much fun doing it as I had resetting it. But some people have been asking me what the exam is going to be like. So I'll give you a broad overview of what it contains. You can't read that, but let's zoom in on that. You can go and check this on the blog anyway. There are 20 multiple choice questions asking you questions about some of the questions will be about what do certain code what do you use an if statement for, what do you use a while statement for, what do you use a for statement for, and then there'll also be some code comprehension questions in there, like after doing this, executing this line of code, what is the value of this variable? And there are a fair few of those. They vary in difficulty, but they're all worth 1 mark each. There's also a couple of questions basically from the lecture notes, as in what is the definition of a blah, 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 blah. So then there are 20 multiple choice, 5 short answer questions about sort of general knowledge about programming questions. So they're more or less definitions of terms or meaning of ideas. I won't give you any examples, or I'll actually give them away. But yeah, if you can, if all the answers to those will be in the lecture notes. But they're more about the kind of principles of programming kind of ideas that I've been trying to drum into you. Then there are 2 5 mark questions, which are longer pieces of code where you have to work out what they do and explain what the piece of code, what the result of that piece of code is going to be. And then there are 2 10 mark questions which are longer actual code writing questions, where we'll say, okay, here's a task for you, write a piece of code that does this, and they'll be of the same sort of nature as the lab questions you've been getting. You will not be expected to memorize the whole Unity API, so all that script reference stuff that we keep referring back to, all of the relevant classes from the script reference I'll give you documentation for. So that'll include, the pages for the vector3 and the page for transform and the page for whatever other classes come up in the exam. You won't be expected either to get your syntax exactly right. So I don't care whether you get all your semicolons in the right place and whatnot. When you're doing it there on paper without a computer, it's not necessary, that's not the kind of thing we really care about. But what we will care about is that you get the meaning of the code right, so that you illustrate that you kind of know how to solve the problems, or at least how to get the computer to do the kind of things you want it to do. So that's the kind of layout of the marks. It's worth, I think I said it's worth 60% of your final mark. So yeah, that's it. I don't think it's going to be, it's not just a trivial exercise. You should put some work into preparing for it. But if you can do the lab questions, and if you can understand the code that we're doing in class, and if you read through the lecture notes and make sure you've got sort of all the key ideas, then you should be able to do it all right. So any questions? Yes, you at the front. Yes, you.
Were you able to get any past exams?
No, unfortunately, past exams. Well, for one, past exams aren't available. One thing, this year's exam is quite different because it's in Unity, but also the past exams have been non-distributed ones. So no, I'm afraid we can't. There's no. Any other questions? Okay, cool. All right. So let's get on with what we're doing. So just to go over the couple of ideas that came up in last lecture that I didn't have slides for. We encountered the idea of having the null object when we have some when we want an object, a variable which normally refers to an object, but we want to have the idea that there is no object at the moment, we can use the value null to represent an empty variable, a variable that doesn't refer to anything at the moment. In the inspector, so inside Unity, it comes up as the value none, and so normally when you create a variable which is an object variable, it'll have the value none until you set it to something. In scripts, we refer to this value as null, and we can use the keyword null to test this value anytime. So we can use it explicitly in our code to represent the idea of no object. So for example, if we have a target, and say the target is a variable that's a game object, if we want to test whether or not we currently have a target, we can say, okay, if the target is equal to null, then currently we have no target. And so if this was some sort of tracking device, when there was no target, it would just, well, do whatever is appropriate to do at that time. Otherwise, say here we want to actually, if we do have a target, let's destroy it. And then once we've destroyed it, we don't want to keep tracking on that target anymore, so we'll set our target to null. And so we can use this value explicitly to say no object. And null is no object in the sense of any kind of object. So not just a game object. Null can be used to represent a no vector or no, not a vector actually. No, if you've got a variable which is a transform or a variable which is any kind of component, you can also set it to null to say there is no value here at the moment. Now this only works for object variables, so you can't do it for ints, floats, and booleans and those kind of what are called primitive variables. But it's a very useful way of indicating that we have we're referring to nothing. We've got to be careful not to try to access methods or properties when a value is null. This will cause a null reference exception, and I haven't got an example there, but if you have a variable, if we go back to the variable target, if we tried here, if target was null, if we tried in here to access some property on target, say target.transform, it would throw, Unity would quit with an error saying that there was a null reference exception. Actually, it probably wouldn't quit. Unity tends to keep going after errors, but it throws an error in the console. You'll see this most often in your console. Let's just put that up there. If you are using a prefab in here, and you don't actually set it. So if we wrote this, where's the Unitron? There's Unitron. Let's drag it over here. If we, so we wrote create brick and we said it had a brick prefab, which is a game object, but we haven't initialized this. We haven't initialized this to any value, and so initially it's going to be none or null. So in the inspector, go over here. In the inspector, this will initially say none. It's a game object, but it has no value. And if we ran this in the way that we're doing, then when we got to when we got down to here to try to instantiate the brick prefab, we'll be instantiating this value will still be null, and you can't instantiate nothing. And so what happens when we run that is okay, down here we get an error. So we bring up the console, you can't read that, but what that says is null reference exception, the prefab you want to instantiate is null. So you're giving it nothing. You're saying instantiate nothing, and it can't do that, so it causes an error. So anytime you try to do something like access a method or a function or a property on a null object, you'll get that kind of error. So it's one worth watching out for. So we put that back to where we were. Brick. There we go. The other thing that we talked a little bit about was functions. I wrote, if you remember, I wrote those functions to work out whether we were above, below, left, or right of a brick. Now we've encountered writing functions before, but well, we were writing methods before more, so we were writing functions to do something. I'll just go over the fact that, you know, the reason that we do create functions is that they allow us to divide our code up into meaningful chunks and give those chunks names, and this makes our code easier to, we can reuse those chunks in different places in our code, so we only have to write that code once and we can reuse it many times. It also makes our code more readable because we can give names to complicated ideas. So rather than just having all the sequence of code, we can take a chunk of code and give it a particular name. And by localizing our code to particular functions doing particular things, it also makes bugs easier to find and fix. So when there are errors in our code, it's easier to work out where they are if we have some idea about what function they occurred in. Rather than if they just encode in a big mass of code. The thing that we noticed that was different this time was we were talking about function return values. Now we've already encountered this. We've used lots of different functions that return values. getKey returns booleans, transform direction returns a vector, getComponent returns a component object. But what I showed you was how to write a function, your own function that returned the value. And the key thing here is the use of the return statement, which basically we have return and then the value that we want to return, and this is the number or the object or whatever type it is that we want to send back. So if this is a function to calculate the area of a circle, the input parameter is the radius. We calculate the radius times 2 times pi, and we return that value, and the calling function will get back. So if we put in the value 1, we'll get back the value 2 times pi. And so this is and then we can use this as a function just like we used any of the built-in functions. When we hit the return statement, we exit the function immediately. So any code after the return statement doesn't get executed. So if we put more code in our area function down here after the return statement, these would never be reached. So usually a compiler will complain that, well, will warn you that you've got unreachable code in your program. Unity isn't smart enough to work that out, unfortunately. So, or at least, yeah. So you've just got to watch out for this. Never write code down here because it'll never get to it. The compiler, well, when it's executing, it'll come in here, hit the return statement, jump back to wherever it came from immediately. And so this doesn't happen. If we have code that has conditional parts, and so there are many different paths through our code that we can execute, we can have multiple return statements in different paths. So if we wanted to compute the maximum of these two numbers, for example, we could test if A is greater than B, then we return A, otherwise we return B. And so now we have two return statements in two different paths in our code. And so if we come in this way, then we'll return from here. If we come in this way, we'll return from here. So we can have many different return statements if we want. You must have a return statement for every path, which is the important thing. If we had just one return statement in here and then didn't do anything down here, there would be an error, because we're returning here, but we don't have anything to return. If B is greater than A, we get down to here, there's no return statement. The computer doesn't know what value to send back. So if you've got a return statement anywhere in your function, you should have one for every single path in your code. Usually you'll have code which has, usually a code only has one return statement at the end, and might have some premature returns earlier in your code. So you might say, you know, if this, then return, blah, blah, blah. Otherwise, if this, then return, otherwise, blah, blah, blah. And then the final case, when you get to the end of the method, it'll say return something. You can also use return in your methods, even when you aren't returning a value. I did not have a note on this. You can say return without a value, which just exits the function immediately. So if you have a method that isn't meant to be calculating any value, so it doesn't have a return value, but you just want to quit it early, you can say return at any point, and it'll exit the thing. If I keep saying return, the word loses its meaning. So that was the stuff that we did last time. Going back to our breakout game. What I wanted to talk about next was, so what I wanted to know how our game works and does everything that we designed it to do. Although actually I found a bug in it, but never mind. We'll sort that out later. What I want to do next is make our array of bricks look a little bit prettier. And so what I want to do is have each row of bricks be a different colour. I've decided to, and we'll make them worth different points when we get to adding points. So the way that the problem that we have here is we want to specify, you know, however many different colours there, 5 different colours for 5 different arrays of bricks. Now, what I could do if I wanted to do this in a fairly stupid way is I could say variable color 1 equals color dot red. Variable color 2 equals color dot. Fortunately, the color class has a bunch of built-in color names. I don't know if we have a look. Scripting reference, where is it? Scripting manual. So the color is a class that represents a color. And there are some built-in ones: red, green, blue, white, black, yellow, cyan, magenta. So all the sort of very basic colours. So if we say color 2 is magenta, and we could keep going in this fashion and do 5 different variables for 5 different lines. But if we wanted to change, well, we have a parameter here in order to say the number of layers in our thing. So we should be allowed to change the number of layers on the fly in our code. So if I wanted to change this and have 10 layers, I could just change that number. Now, if I wanted to have 10 different colours, I'd have to go back and modify the code to add another 5 colour variables, which would be really annoying. And the way I'd do it in here, if I was setting the colour of each layer, I'd have to say, if we are in layer 1, then set the colour to colour 1. And if we are in layer 2, then set the colour to colour 2. And that's tedious and lots of busy work. So we don't want to do that. What we want to do is have some way of representing a list of colours that has one colour in it for every layer in our game. So what we have is, whoops, I pressed the wrong button. What we have is the ability to have a what's called an array, and it looks like this. So we say that this says that the colour with the proper spelling is colour with the American spelling, because anyway. And then the square brackets mean this is an array of colours. So this doesn't just contain one colour, it contains many colours. It's a list of colours. And now if we come over and look in the inspector, we'll see, no, you can't see. If you could see, there would be a drop-down box here which says colour. When I click on it, it says size is 0. But if I change the size to say 5, it now comes up with 5 entries for individual colours, which I can set. And if I change the size to 10, it now has 10 entries there, so I could set as many as I want. So arrays give us the ability to have collections of variables of arbitrary size. So we can have as many of them as we want. So in this case, we want 5 variables, and then I can 5 different colours, and I can pick a colour for each of these if I remember how to do it. Let's just scroll out. Scroll out? No? What do I? Oh, there we go. Oh, there we go, the colour picker. So we'll have that row as red, and this row as sort of a pink, and this row as somewhere further down the hierarchy, somewhere in sort of around there as a purpley colour, and this row as blue, and this row as sort of a brighter blue, a light blue. There we go. So now we can pick 5 different colours for our 5 different layers of the game. Now, okay, so actually I'll get rid of that. It's not anything to do with it. So now, this is handy, but it doesn't actually, now we've got to work out how do we use those colours in order to set the, in order to change the colours of the brick. So down here when we create the brick, we create the brick, we put it in its position, and now we set the colour. Now to access the colour of a brick, the colour of an object, so if we have a look at our brick, the colour of an object is sort of hidden away a little bit. If we have an object, in the inspector we can see there's a mesh renderer here. Oops, there it is. The mesh renderer has a materials field, which hopefully you'll be able to see in the video. And the materials field is actually an array itself, because there can be many materials. But usually when you create something, it only has one material, and that's this first element here, and that refers to this material, and a material has a colour. So getting at the colour of the brick, whoops, wrong way. Getting at the colour of the brick, we have to get the mesh renderer first. So we use get component to get the mesh renderer off the brick. So let me scroll this up. So we can say brick.getComponent mesh renderer. Right, which gives us access to that component. Then we have mesh renderer.materials. Now materials is an array, and each element of that array is a material object. And so we can access elements in that array using this square bracket notation. And the way we do it is in the square brackets we put the number of the element that we want. Now numbers, as I said many times before, computer scientists start counting at 0. So there's only one thing in this array at the moment, which is our standard brick material. So that's array index 0. Now that gives us back the material we want. So we can say material, actually let's not do it like that. So that would give us a material value. So we could say, oh, sorry, I've just got confused. I'm using the wrong syntax. So I've changed languages recently, and I'm just getting back into JavaScript. That's not that, that's that. Okay, sorry, I was just showing you C#. It's a problem when you get to the stage that I'm at, learn so many different programming languages that they all blur together. In JavaScript, we put var at the beginning when we're declaring a new variable. So that's var mr equals mesh renderer. We could say var material equals mr material 0, and that would give us access to that material. Now we don't actually want to stick that in a variable. What we actually want to do is take that material. Actually, no, we can stick that in a variable. Let's stick that in a variable called material, and then let's say material dot. Now I've got to find out. I think it's just dot color. Color equals. Now, what color do we want to set this to? Well, the color that we want is whatever the value of our color array is for this layer. So again, because we've got one entry in the color array for each layer, then we can just use this bracket notation again, which is say color, and then in this case again we're going to use the square brackets to index into the array. But this time the index that we want is what layer we're on. So this says, take the current layer value, which is tracking from 0 to the number of layers, and look in the color array for that value. So if we're on layer 0, it looks for value 0. If we're on layer 1, it looks for value 1. Takes that value and sticks it into the materials color field. So hopefully this will work. Let me see if this works. And it doesn't, because we have, okay, array index out of range. Cool. Color layer. Because, what did we do wrong? I think I know. Bricks. Ah, yes, all right, we changed the color array while the program was running, which is the usual mistake that you make in Unity, and then when the program stopped running, it all went away. So let's go back and set our colors again quickly. Red, pink, purple, blue, light blue. Let's try this again. Hey presto, there we go. Each array has a different color. So it's gone through this array of colors, and for layer 0 it's taken color 0, and for layer 1 it's taken color 1, and so forth. And it gives us a nice brightly colored array of bricks, which we can destroy in our game. So that's the basic notation for accessing arrays. So in general, if we come up to Keynote again, whoops, Keynote, not that. So in general, the syntax, so there are times when we want to access lists of data of arbitrary length. So another example might be if we wanted to have our program keep the names of everybody in the class, right? Now, if we had a separate variable for each person, that would be really annoying because we wouldn't be able to actually, if we wanted to look at, the third person in the class or do some action on every person in the class, we'd have to go and do it we'd have to write explicit code to do it on every variable. So this is really an unworkable way, and we don't know how many people are going to be in the class beforehand, so we can't just create a variable, each variable in our code for every person. That would be stupid. So what we have two different ways in JavaScript, in Unity JavaScript, for handling lists of data. And this is really annoying that they've got two different ways and they've given them the same name. They're both called arrays, which really sucks. So there's what they call built-in arrays, which is what I just showed you. And built-in arrays are for lists of fixed length. Now that length can be that length can change from run to run, but when you create the array, you create it with a certain length. There's also the array class, which is a separate, looks very similar functionality, but actually allows you to have variable length arrays. So the array class, if you can add more elements to it or take elements away from it. The built-in array, you say when you create the array, this is an array of 4 objects, and it's forever afterwards an array of 4 objects. This overlap in naming is confusing. In other languages, they usually call the fixed length things arrays, and the variable length things are usually called lists. I don't really know why they made 2 different implementations with different names, with the same name. It's really annoying. So today I'm talking about fixed length arrays. Later on we'll go to deal with variable length lists. Unfortunately, they're also called arrays. So in terms of fixed length arrays, this allows us to store a list of data for a certain number of elements. We can declare an array like this. So we say it's standard variable declaration, we give it a name, and then a type, and then square brackets to indicate it's an array. So if we left off that would just be a single string, but with the square brackets, that becomes an array of strings. So every element in this array has the type string. For a fixed length array, all of the elements of the array have the same type. Which makes sense because it's a list of names, so all the names are strings, or a list of colors, so all the entries are colors. So we'll encounter later how to have arrays which has different types in them, but usually that isn't a very sensible thing to do. We can also initialize an array, and when we initialize an array, we specify its size. So if we just create an array, declare an array like this with an unknown, with no size in there, then then it's up to you in the inspector to set the size of the array, how big it's going to be. So you can set that in by hand in the Unity inspector. If you want to declare an array in your code as you're going, you'll need to initialize it to say how many things it contains. If we do it like this, we can say new string 3. This creates an array with three empty strings. So it has place in it for 3 strings, but initially they're all empty. Alternatively, we can initialize like this. We can actually say in square brackets the 3 things that we want to have in the array. And so if we have initial values for our array, we don't want them to be empty, we can set them using this sort of notation. And if we had an array of integers, we could set this as being 1, 2, 3, and if we had an array of other things, we could have an array of vectors if we want, and this could be up, down, forwards, or, you know, it doesn't have to be 3, obviously, it can be as many as you want. We can't have different types in here, so we can't initialize it to x2 and vector3.up. That's an error, because an array has to have a fixed type. So this is automatically an array of strings, because all 3 things in here are strings. This is a string, this is a number, this is a vector. There are different types. We can't have an array of different types. Every array has a length, and we can get at that by looking at the array.length variable. So this is useful if we've given an array and we don't know how many things are in it. For example, if it's an array that we've declared in the inspector and maybe it has maybe we put 5 things in it, maybe we put 10 things in it, we can look at the array.length property to see how many things are in that array. Notice that the length is fixed in these arrays, and so this variable is read-only. So if we go back to the previous example, we print names.length, this will print 3 because there are 3 things in that array. If we try to set that variable to 4, this will cause an error because we can't change the length of a built-in array. We can access array elements by index, and this is the square bracket notation I was just showing you. So we have the name of the array, and then in square brackets the number of the index, and this is an integer. It starts at 0 and goes up. If you try to access negative elements, you'll get an error. We can, did I just skip I think I skipped a slide. No, that's interesting. I lost a slide somewhere along the line. Okay. Oh, I must have accidentally deleted a slide. So we could, if we wanted to get at the variable, if we just wanted to print the value at an index, we could say print names1, and it would print out whatever name 1 was in our list before. Name 1 was originally Jose, right? Because this is 0, this is 1, this is 2. So if we printed out name 1, we'd get Jose. If we printed out name 0, we get Bob. If we printed out name 2, we get Anushka. If we printed out name 3, we get an error because there is no element 3 in this list. We can also set the values in our array using the same notation. So we can say name 1 is Carl, and now we've changed name 1, and so now the array will show Bob, Carl, and Anushka as the 3 elements. We can't set elements, keep going on this, we can't set elements beyond the length of the array, so we can't set the 3rd element because there's only, well, we can't set the element 3 because element 3 is beyond the end of the array. We can't set the elements to a different type either because arrays have a fixed type. But this is generally a useful way of, there's a slide missing, but the slide missing was talking about how to access these things. I'll add it in there. But this is a really useful way because we don't necessarily have to know how many things are in our array when we're using it. We can just access them by length. And in fact, what we can do here in our code, because we know that our array of colours is going to be, we know that our array of colours has as many elements as there are layers. We can actually say new colour n layers, which means that now when it runs, it'll automatically create as many entries as we have layers. Now, one thing that won't work there Actually, come to think of it, will that work? Yeah, okay. That won't quite work. Well, it won't quite do what we want. Let's just remove that. Go away. Come on, figure out that I've... Oh, what have you done? Oh, okay, it's an error. Anyway, the if we... how do I do this? Sorry, just a second. It's annoying trying to get the inspector to forget about the... when you change the values, the inspector doesn't go back, won't let you go back again automatically. So if we did that, anyway, this would create, because number of layers is initially 5, this would create 5 colours. Now if I went and changed number of layers to 6, it wouldn't automatically change this because this statement only gets run once when the object is first created. And so if I change the number of layers, I'd actually have to change this by hand as well. So watch out for that. The other thing we can do is, since the number of things in the colour array tells us how many layers we have, we can actually just do away with the number of layers and just say, we can do this. We can, oops, delete that if I can find that. We can remove that variable entirely. We don't need that anymore. And what we can say is color.length. Right? Now the number of layers we have is just determined by the length of this array. So if we come back over here, we've got rid of the number of layers, but it still creates 5 because there are 5 things in our array. If we wanted to change this to 6, it'll add another element. We can pick that element to be green. Oh, no, that's an ugly shade of green. Green, there we go. And now it's got another layer because the number of layers is now equal to the number of colours. So we automatically we can create as many layers as we have colours. It's usually a good idea when designing your code to not have redundant information. So if the number of layers, if there are 2 places where you have to specify the number of layers, once in the list of colours and once in the variable number of layers, then every time you want to change the number of layers, you've got to change both of those variables. It's usually a bad idea to have that kind of redundancy because you'll end up changing the number of layers and wondering why your code crashes because you forgot to change the number of colours in the colour array. So if you've only got one source of a particular piece of information, that makes your code more maintainable. So in this case, there's no point in having a separate variable which says the number of layers if the number of entries in the colour array already tells us the number of layers that we want. Now it would be trickier than that. We can't always do that because say we also want to say the number of points value, which is also an array. So which tells us the points value of every brick. Now we'd have to make sure that this points value array, which is an array of integers, if we have 6 layers in the color array, then we also need 6 layers in here, which says the points value of each layer. And there's no easy way to make sure that this always has 6 if this has 6. That's something you just have to maintain by hand. But this would give us a way of saying, you know, the top value, the top bricks are worth 500 and the bricks below that are worth 200. 200 if I can type, 200, yes, and the bricks below that are worth 100 and all the bricks below that are worth 50, something like that. So then if we go and implement points, we now have a way of saying different layers of bricks have different amounts of points attached to them. So that's the general idea about using arrays. I really didn't have more about that I wanted to go into today. Actually, there was a bug in the code. Yeah, I know I've got a lab in 15 minutes. There was a bug in the code that I didn't like that I figured out afterwards. If we remember how we had that wall down the bottom when it wasn't colliding with the wall down the bottom properly. So if I actually bring that wall up, let's put this that way. If I bring that wall up somewhere where we can see it, we can see when the ball hits the wall to the bottom, it goes straight through, and it was meant to be bouncing off. In fact, if I bring that even up higher so we can hit it, it doesn't work. And the reason why, and I was trying to work out why it wasn't working, and I think the reason why it doesn't work is that what I did when I created that wall is that I took one of the side walls and copied it and rotated it, and the problem is it's facing in the wrong direction. Because we're using the local transform on the wall to work out which way the ball should bounce off, this wall is facing up that way rather than up that way, which means that it's not going to work. So if we took this wall and rotated it back the way it came, so we set this rotation back to 0, and now we need to change that to 12 and that to 0.5. So we stretched it in the other direction. Now that should work. Yeah, so now that wall works. So that's a fix for the time being. But what we'd really like to do is have that idea of which way up an object is not matter at all. So in the 10 minutes remaining, what I'm going to do is fix our program so that we can have our bricks and walls in whatever angle we want. And in particular, I'm going to go grab a script that I wrote for last week's lab, import new asset. Should be here somewhere. Unity, breakout levels, assets, circle, import. Okay, so now what we're going to do is take bricks, and I'm going to put the circle on there, remove that one, or disable that one at least. So that should now, but doesn't, oh, because I didn't set the prefab. Set the brick prefab in there. Oh, it's up there. I need to move that. To about there. Let's remove a couple of layers from that. Let's make that 3 rings. There we go. So now this doesn't quite work the way we'd expect. Oh, it hit the top wall. Okay, so the top wall's got the same problem as the bottom wall in that it's lined up the wrong way. So let's just duplicate the bottom wall, delete the old top wall, and we'll take this and call it top wall. And put it up the top. There we go. Somewhere around about there. A bit further up. A bit too far. Oops. There we go. So now if we, see now it's not quite bouncing off things. It's not bouncing off the bricks that are pointing in the wrong direction, or at least it is bouncing off them, but it's not bouncing off in the sensible way that we want it to. And the reason for that is that we were assuming when we did our code for bouncing off, let's have a look at the code for that on the ball. We had our ball move script, and we were assuming that, if we come down the bottom here, that when we collided with an object, if we collided with the object, say from below, then we would now start moving down. Now that made sense when we were. Where's a piece of chalk? Is there any? No. Okay. No, there isn't any chalk. Okay, that made sense when all our bricks were aligned with the same axes as up, down, left, and right. Because when we were hitting the brick from below, the right thing to do was to move down. But if we have a brick aligned at an angle, then in the local coordinate space of that brick, anywhere over here is below, anywhere in that section of the world. And sometimes that isn't so the way we bounce off would be if we were going up, we'd bounce off down, even though the brick was angled that way. So what we want is to actually bounce off at an appropriate angle, right? I would draw it if I had anything to draw with. So whichever way our brick is angled, we want to bounce off at the right angle, and not just bounce down if we hit it from what that brick thinks is below. So I was going to in the 5 minutes left, let's see if I can do this. In the 5 minutes left, I'm going to fix this. The way I'm going to fix it is rather than having moving up and left, I'm actually going to keep track of our direction in here, which is a vector 3. And I'm going to get rid of all of this complicated stuff and just say we're going to move in whatever our direction is. Direction. Initially our direction is going to be, we're going to initialize our direction so that when we start moving, so when we first create the thing, we need to set a value for direction. Let's not do that in there, let's just do it in the inspector so we can, so now we have a direction field. We're going to say initially when we start moving, we're going to move in direction, actually, yeah, right. So we're going to move up and up and right. So X is positive, so it's going to move right, and Y is positive, so it's going to move up. So that should actually initially move us that way, which is good, but we don't have any collision happening now. So that works. Actually, we should normalize that because, so let's do that. So when we start, we'll just say direction dot normalize, there we go. It's because the direction, we want the direction to be always a length 1 vector. So no matter what the user types in here, we should normalize that so it's always length 1, so that it's just a pointing in a direction and it doesn't change our speed when we change how big it is. So that does what we want. Now what we need to do is handle collisions appropriately. Now now what do we do here? And this is interesting, and this is where I really need to draw something on the board. No, there is no chalk. Okay, so when we hit a brick from below, what we want to do is bounce off. So if we hit a brick that's normally oriented, if our direction is that way, what we want to do is take the up component of our direction and reverse it. So we're still moving left or right at the same speed as we were before, but where we were moving up, we're now moving down. Now the same is true no matter which way we orient the brick. In the local coordinate space of that brick, we're just changing up and down. It's really hard to do this without being able to draw you a picture. Now, I'm going to write the code and we can talk about it later. So what I'm going to do, just to be tricky, is I'm going to take the direction that we're currently moving. Sorry, I'm just grabbing code from elsewhere. So we take the direction that we're currently moving and we're going to transform that direction into the local coordinate space of the brick. And so, whoops, excuse me, jumping around. So by transforming it into the local coordinate space of the brick, it's now moving this new vector is a vector in that coordinate space. So up up for this vector is whatever's direction is up for that coordinate space. So now what we can do is if we're moving up, if we hit something from below, we can now set d dot y, which is the amount that we're moving up, is equal to negative d dot y. So we're going to bounce, if we hit something from below, we're going to invert the y component of that vector, which is going to make it move up. If it's moving down, it's going to make it move up. We can do the same here. If we hit something from below, we're also going to invert the y component. If we hit it from the left, we're going to invert, or the right, we're going to invert the x component, which makes us move in the other direction. Now what we need to do is take that and set our new direction is, and we take this big chunk of code here. So we've now got a vector, we've now bounced in the in the local coordinate space of the brick. So now what we need to do is transform that direction back into the world coordinate space, and this should give us what we want. I have no idea, I haven't actually tested this. But let's see whether that works. This is, whoa, and I've got lots of errors. Unknown identifier brick, okay, I can fix that. Let's just call find and replace brick with what? Next. Replace, no. Okay. Let's try that again. Hey, all right. So now it bounces off, whoa, in whatever the appropriate angle is for the thing that we hit. Whoa, which is kind of cool. If you didn't follow that, I totally understand. That was really rushed and impossible to understand without the aid of diagram. But it's kind of cool anyway. Oh, come here. Anyway, you can sit and watch me play Breakout all day. All right, thank you for coming. I'll see some of you in labs. Otherwise, see you next time on the Muppet Show. Thank you.